Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers Edexcel Paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Question 1. Write 31% as a fraction. Well, 31% literally means 31 out of 100. So that's pretty easy really, isn't it? 31 over 100. Question 2. Change 3 meters into centimeters. Well, 1 meter is how many centimeters? It's 100 centimeters, isn't it? So if I've got 3 meters, it's going to be 3 lots of that. It's going to be 300 centimeters. 300 centimeters. Round 32,629 to the nearest thousand. Well, the thousands are this digit here, aren't they? That's the thousands. The 3 is tens of thousands, the 2 is thousands, 6 is hundreds. So I need to round off after that too. That's the cut point. So everything after that cut line is going to get thrown away. But just before we do, we just need to check out the value of the next digit along, which is 6. And then if it's 5 or more, we need to raise the score. We're going to round up. If it's 4 or less, we need to let it rest. We're going to round down, and in this case it's 5 or more, so I'm going to round this one up, aren't I? So my 32 at the beginning is going to go one up. It's going to go 33. Now 33 is not a good estimate of 32,629. My rounded number has to have the same magnitude. That 3 at the beginning was tens of thousands, so we need to make this number tens of thousands again just by adding some extra zeros on the end. Okay, so just check your answer is the same magnitude as what it was to start with. 33,000. Next we need to round 32,629 to one significant figure. Now the first significant figure is the first non-zero digit of your number. That's the 3. Okay, so in this case we're going to be rounding off right after the 3. Okay, now the next digit along is this time is a 2, which is 4 or less, so we need to let it rest. We need to round down in this case. Okay, so the 3 at the start is going to stay being a 3, and we're just going to then add on enough zeros to make our answer the same magnitude as it was to start with. So adding 4 zeros, I'm going to get 30,000. Okay, another way of thinking about it is the first significant figure is in the tens of thousand column. So just round your number to the nearest 10,000. So you can see that 32,000 is closer to 30,000 than 40,000. A circle has radius 5 centimeters. Work out the circumference of the circle. Okay, so I've got a circle. Radius is the distance from the center to the edge. That's the radius. So this has got a radius of 5. Okay, so then to work out circumference, cherry, pie, delicious, apple, pies are 2. Okay, then my 2 formula for circles. Cherry pie delicious circumference equals pi times diameter. Area, apple pies R2, area equals pi times R squared. It's just a silly way of remembering it. So cherry pie delicious, apple pies R2. Now in this case we want circumference, don't we, which is this one. But this one it's in terms of D, isn't it? There's another way of writing this. There's two approaches here. We could just work out what D is. D is 2 lots of the radius. It's going to be 10, isn't it? It's going to be twice as long as the radius. Or you can use 2 pi r as well. That's another formula you can use. Okay, I'm just going to convert or find D. D is 10. Diameter that is, and then sub it into my formula. So C equals pi D equals 10 lots of pi then, isn't it? So pi is 3.14, so that's just going to be 31.4 what? 31.4 centimeters. It's just in flat units, isn't it? So 31.4 centimeters, you could do that on your calculator. I just happened to know that pi was 3.14, so it just saved me typing it in. Work out the area of the circle. So we did the circumference one first. Now it's time to move on to the area one. Area equals pi r squared. Apple pies R2. Then subbing in, this time r is 5, so it's going to be pi times 5 squared, isn't it? So 5 squared times pi, which is 25 pi. What's that? Tap that into the calculator. So 25 times pi. You've got a little pi symbol on your calculator, so just use that. So that's 78.5 and change according to my calculator. Just going to round it off to 3 significant figures. 78.5. Let's write the following numbers in order of size, smallest first. Okay, so I like to try and compare these digit by digit, moving from left to right. So now they all start with a 0. That's the same for all of them, isn't it? And actually the next digit along is the same for all of them as well. Okay, they all got a 5 there. Then things get different on the next digit, don't they? So on the next digit along, we've got a 2, a 4, a 1, and a 0. And that's what I'm going to rank them on then. I'm going to rank them on that digit. So the smallest one first is the one with the 0 in it then, isn't it? So that's 0.502. That's my smallest one. The next one is going to be the one with a 1 in it. So that's 0.51. And then I'm going to look at the one with a 2 in it, which is 0.529. And then I'm going to look at the one with a 4 in it. So that's 0.54. Okay? So just make sure you're comparing like digits with like digits when you're doing these. Question 6. Here is a list of whole numbers from 21 to 30. From the list, write down a square number. Well, square numbers are numbers that you times by themselves, and then that's your square number then, isn't it? So the first square number is 1. 1 squared is 1. That isn't on the list. Next square number is 2 squared, which is 4. Then I've got 3 squared, which is 9. 4 squared, which is 16. 5 squared, that's 25. Now that one is on the list. Okay, it's here, look. So I think it's going to be 25. Now the next square number after that is going to be 6 squared, which is 36, which is too big, isn't it? It's off the list. And then part B, from the list, write down a multiple of 8. Well, the multiples of 8 are 8, 16, 24, 32. And the only one that's on the list then is the 24. Okay, so that's the one I'm going to pick. So 24. Question 7. The pictogram shows information about the houses in a street. Each house has 3, 4, or 5 bedrooms. And we've got a pictogram here, and we've been given a key at the top, and it says one little symbol like this. That's worth 2 houses. Okay? So if you have a look at 3-bedroomed houses, we've got 1, 2, 3, 4 houses and a half a house. So 4.5 houses. So that is going to represent altogether 4 times 2 is 8 plus half times 2 is 1. So that's 9 houses altogether, isn't it? So that's 2, 2, 2, 2, and that one is a 1, giving you 9 altogether. Okay, 4-bedroom houses, got 5 complete houses there. 5 times 2 is 10. And then these 5-bedroom houses, again, we've got 1 complete house, which is worth 2, and a half house, which is worth 1. So that's altogether is equal to 3. So in total, how many bedrooms do all the houses have altogether? We just need to add all those up then now, don't we? So 9 plus 10 plus 3, that comes to 22. So that's my answer. 22 bedrooms. Jack and Liam each get the same pocket money. Jack spends 75% of his and has £2 left. Liam spends 40% of his. How much does Liam have left? Well, if Jack spends 75% of his and he gets and he's got £2 left, then 25% is what he has left, isn't it? And that is equal to £2. So if 25% is equal to £2, then 100% is going to be 4 lots of that, then, isn't it? Okay, and 4 lots of £2 is £8. So that means that Jack must have had £8 pocket money to start with. Now we know that Liam has the same amount of pocket money, so he must also have £8. So if he spends 40%, then he's got 60% of his pocket money left. So what we need to do is to find what 60% of 8 is. So using our triangle, final, original, multiplier. Our final is what we're trying to find. Our original is £8, and our multiplier, let's say we want to find 60%, don't we? 60% of the amount, which has a multiplier, is 0.6. So to find our final, just cover that up, is original times multiplier. Final is equal to original times multiplier. So 8 times 0.6, which is, according to my calculator, 8 times 0.6 is 4.8. Now remember, this is money though, so we're going to have to write that as pounds and pence. So he's got £4.80 left. Now you could have also found out what 40% was and deduct it from the £8 to get the same answer if you wanted to, but this way is quicker if you know what you're doing. Sandip is going on holiday. She wants to change £400 into euros. Bank A will change her £400 into €452. Bank B changed £250 into €280 for Sandip's friend. It will use the same rate to change Sandip's £400 into euros. At which bank will Sandip receive the most euros, and by how many? Show your working. Okay, so we know what's going on in Bank A. We just really need to work out what's going on in Bank B, don't we? Now Sandip's friend took £250 and she changed it into 280. So we can use those two figures there, that one and that one, to work out the exchange rate. So the exchange rate is going to be, well, let's take the 280 and divide it by 250, and that will tell me how many euros I'm going to get for each pound. Okay, so the exchange rate is 280 divided by 250. That comes out to be 1.12, which is basically £1 then is going to get you €1.12. Okay, so then if I then have £400 to change, I'm going to take my €1 and 1.12 euros and I'm going to times it by 400, and that's going to give me 448. Okay, so 448 euros from Bank B. Now we got 452 from Bank A. So Bank A is going to give her the most. Okay, by how much? Difference is going to be what she got in Bank A, 452, minus what she gets from Bank B, 448, and that comes out to be 4. So Sandip received €4 more. Okay, might buy her a, drink at the bar or something. Shape is made by joining a right angle triangle to a rectangle. Okay, and then we need to work out the area of the shape. Okay, so we've got two different shapes. We've got area 1, which is a triangle, and we've got area 2, which is a rectangle. Okay, so let's work out area 1 first. Area 1 is a triangle, so triangles normally have an area of half base times height. Now, base doesn't have to be the one on the bottom. Just your base and height need to be at right angles to each other. So I can use this side here as the base, and I can use this side here as the height because they are at right angles to each other, and so that would be perfectly acceptable for finding the area. So then that is going to be a half times 30 times 16, just subbing those values into my equation, and then half of 16 is 8, and 8 times 30, 3 8s are 24, and a 0, that's 240, isn't it? So that's going to have an area of 240 centimeters squared. What about A2? A2 is slightly more problematic because, well, it's a rectangle, it's got easy formula for finding it, but we only know one of them so far, don't we? We know this length here is 52. Okay, so one of them is going to be 52, but what is the other one? We don't actually currently know this one, do we? Okay, we haven't got that one. But you can see that that side there, which is going to be the width of this rectangle, is the hypotenuse of that right angle triangle, isn't it? So I can just use Pythagoras Theorem to find this one. Okay, so here I can use c squared equals a squared plus b squared, where a is 30 and b is 16. Okay, so what's that then? 30 squared plus 16 squared comes out to be 1156. Okay, so then c is going to be the root of that then, isn't it? Root answer, that's 34. Okay, so that means my hypotenuse is 34, so that's 34, so that's 34. Okay, so subbing that into my calculation here, 52 times 34, times that by 30, 52, going to get 1768. And so then the area is going to be those two things added together then, isn't it? So it's going to be 240 plus 1768. And that comes out to be 2008 units centimeters squared. 240 people go to a rugby match. 183 of the people support the home team and the other people support the away team. 162 supporters are male, 45 of the away supporters are male. Complete the frequency tree. Okay, so every kind of level of the frequency tree is going to have to add up to 240. So I've got 240 in my first kind of level, and then I've got home and away. So my 183 and whatever appears here has to add up to 240. So 240 subtract 183 gives me 57. So there are 57 away fans on the day. Now, of those 57 away fans, we know that 45 are male. So 57 subtract 45 leaves me 12 that are female on that date. Okay, so I've just got these male and females from the home team to place. Now, I was told something about that earlier. I was told that 162 of the supporters are male, and we already know that 45 are away fans, so the rest of those males must be home fans. So what is 162 subtract 45? That is 117. So that means that I must have 117 male home fans. Okay, now I know that I've got 183 home fans, of which now I know that 117 are male. So if I take 183 and I subtract 117, it leaves me with 66. So that means I've got 66 home female fans. That's it, my table's complete. Reflect the shape A in the mirror line. When you're reflecting shapes, don't try and reflect the lines. Reflect the vertices or the corners of the shape. This shape has got 3 vertices, here, here and here. Now what I like to do is I want to count how far away each one is from the mirror line and then reflect it that amount of points on the other side. So if you have a look at this one on the right, that lies 2 units away from the mirror line. So its image point is going to be another 2 units away on the other side. So its image point is going to be here, look, okay? If I do the same thing with the other ones, look, this one is 3 units away from the mirror line. So its image point is going to be 3 units away as well. It's going to be here. And then finally, the other one there is 4 units away. So its image point is going to be 4 units away. It's going to be there. Now, once you've reflected all the shapes, then you can join them up with your ruler to create the actual lines of the shape. Okay, now it's much easier to do that than trying to reflect the lines. If you try and reflect the lines, you're going to go wrong. Okay, so we normally label images of things the same name, the same letter, but with a little dash like that. So the image of A is A dashed. Okay, so I'm done. To rearrange this formula to make W the subject. So again, just as I was saying, you can see that you've got 3 unknowns in here rather than just 1. So it is a formula and not just an equation. If we want to make W the subject, we need to rearrange it so that I get W by itself. Now you can do this very much the same way as you do equations, by kind of adding, subtracting, multiplying, dividing things from both sides. Okay, so we want to try and isolate W, which means we want to try and get rid of everything else. Okay, now at the moment W is times by 2 and I've got 2h added to it. Now the order that you do this is like BIDMAS but backwards. So if you think about BIDMAS, then I've got a multiplication in here and an addition. So multiplication comes before addition normally in BIDMAS, but when you're rearranging these, you kind of go through BIDMAS backwards because you're kind of using inverse operations to work your way through. So that means I need to deal with the addition first. Now the opposite of adding 2h is subtracting it. So if I subtract 2h from both sides, it will cancel off this side, and what I'll get is p minus 2h is equal to 2w. Okay, and then now I've got 2w by itself, but I want w by itself. So I'm going to divide both sides by 2. That side is going to cancel with that one there, so I'm going to leave me with w on the right, and I'm just going to get p minus 2h over 2 on the left. Okay, that's all I'm going to do. Well, that's kind of the answer. I'm just going to spin it around actually and write w at the front. So w is equal to p minus 2h over 2. That's my final rearranged answer. Here are the first 3 terms of a sequence, 23, minus 14 and 9. Now we're told that each term is obtained by adding the previous 2 terms together. So that's a bit like the Fibonacci sequence. Now normally with the Fibonacci sequence we start with 1 and 1. Here we've got 2 different starting points, but we're following the same rules, that we take this one and this one, we add it together and it gives us the next one along. Okay, so what is the next term in this sequence? Well, the next term I'm going to get by taking my minus 14 and adding on the 9. That's going to give me the next number in the sequence. So negative 14 plus 9 is minus 5. So my next term in the sequence is negative 5. And then my next term I'm going to get by adding 9 and negative 5 together. So 9 plus negative 5 is 4. So I'm going to get negative 5 and 4. Right, now part B says the sequence continues. How many negative terms are there in the sequence? Okay, well, we've had 2 so far. We've had minus 14 and minus 5. Now what's going to happen next? What's going to happen as our sequence continues? I think we're going to need a few more terms, aren't we, to work this out. So we know that there are Well, we've already got 2, so, but will there be 3, 4 or more as the sequence continues? So let's just write down the sequence again. 23 minus 49 minus 5, 4. Oops. So we've got 23 minus 14, 9 minus 5, 4. Is that right? Yeah. So what's the next term in the sequence? The next term is I'm going to get by adding minus 5 and 4 together. So negative 5 plus 4 is minus 1. So there's at least 3. And now my next term after that, I'm going to get by adding 4 and minus 1 together. 4 plus minus 1 is 3. And then my next term I'm going to get by adding minus 1 and 3 together. So after that I'm going to get 2. And my next term after that is adding 3 and 2 together, which is 5. Now notice now that everything is positive. From this point on, I'm just going to get more and more positive numbers, aren't I? Because 2 plus 5 is 7, 5 plus 7 is 12. After that, my whole sequence is going to be positive forevermore. So how many negative numbers were there? I had my minus 14, my minus 5, and my minus 1. And after that, everything is positive. So 3. Use your calculator to work out 9.95 squared times 29.8. Okay. So we've managed to gain quite a few marks already in this paper just by being able to type nicely into my calculator. So 9.95 squared times 29.8 equals, write down your full calculator display. So 2950.2745. Okay, that's what I got. Right, question 14b. Is your answer to part A sensible? Use approximations to decide. You must show your working. Okay. So what asking me to approximate that answer now and compare it with my answer to make sure that I did it correctly. Okay, so let's do that then. So if I look at 9.95, I'm going to round each one of these numbers off to one significant figure. So the first significant figure in 9.95 is the 9, which is in the units column. So 9.95 to the nearest unit rounds up to 10. So I'm going to get 10 squared times 29.8. So the first significant figure of this number is the 2, which is in the tens column. So let's round 29.8 off to the nearest 10, which is 29.8 is nearest to 30, isn't it? It's nearer 30 than 20. So it's going to be 10 squared times 30. Okay, so let's work out down here 10 squared times 30. Well, that's just 100 times, not 106, 100 times 30, which is 30 with 2 extra zeros, 3,000. Okay, so my estimate was 3,000. My actual answer was 2,950. So that's not bad, is it? It's only 50 out, which is not too much when you're talking about thousands. So yeah, I'm going to say it was sensible. Question 14. Nazima uses this graph to find out how much money she is paid for a number of hours she worked. And so we've got hours worked along the bottom and we've got her pay along the side. So it's a conversion graph, isn't it? So how much money is Nazima paid for each hour that she works? Now we can work that out by kind of looking up from 1 hour then, can't we? If we look up from 1 hour, we'll work out how much she gets paid for 1 hour. So let's read up from 1 until we hit the graph. And then we're going to spin around and go the other way. It's a good idea to show your method on the graph like this. It's kind of pointing, it's kind of halfway between that little square there, isn't it? Now I've got like 5 divisions between 10 and 20. So each division is worth 2. So I think there are 2.5 divisions, and that's going to be worth 5 then. So I think that's pointing at 15. So how much money is Nazima paid for each hour that she works? She's paid £15 an hour. Okay. Last week, Nazima worked for 36 hours. How much money was Nazima paid? Okay, so this graph isn't going to do us very much good, is it? Because it runs out at 5. So no good at all. So let's reach for the calculator instead. So if I've got £15 per hour for 36 hours, then let me just write that down, because if you type something into the calculator, you should really write it down, shouldn't you? So wages equals 15 hours at, sorry, £15 times 36 hours, and that comes out to be £540. Okay. And the height h of a lorry is 4.3 meters, correct to 1 decimal place. Complete the error interval for the height h. Okay. Now I like to do these with the number line. I draw a number line and I mark on the number that they've given me, which is 4.3. Okay. So then we know it's correct to 1 decimal place. If I was drawing a scale and that was going up in numbers to 1 decimal place, then the next one up on the scale would be 4.4, and the one below it would be 4.2, wouldn't it? It'd be 4.2, 4.3, 4.4. Now the numbers that round to 4.3 are going to be the numbers that are halfway between 42 and 43 or nearer, or halfway between 43 and 44 or nearer. So basically this range of numbers are the numbers that round to 43, aren't they? Okay. But what number is halfway between 42 and 43? Well, I know that that is 40, sorry, not 42 and 43, 4.2 and 4.3. It's 4.25. If you're not sure, you could just add the two numbers together and divide by 2, and that would tell you on your calculator. And the other one then is going to be 4.35. That's halfway between 4.3 and 4.4, isn't it? Okay. So my lower bound is going to be 4.25 and my upper bound is going to be 4.35. So any numbers between 4.25 and 4.35 round off to 4.3 to 1 decimal place. Question 17. The table below shows the area in square kilometers squared of some countries. Now you can see these areas have been given in standard form. There's a number times a power of 10, isn't it? Write the area of Sweden as an ordinary number. So in the table, Sweden is given as this, 4.5 times 10 to the 5. Okay, so 4.5 times 10 to the 5. If I want to write it as a normal number, I could just type that into the calculator and work it out, or I can work out where the decimal point goes. So times 10 to the 5 will have the effect of shifting the decimal point 1, 2, 3, 4, 5 jumps along. It will go to here, okay, which means there are going to be some extra zeros appearing in here. So my answer is going to actually be 450,000. What's that? That's 450,000, isn't it? Okay. The other way of thinking about it is 10 to the 5 is hundreds of thousands. 10 to the 6 is millions, isn't it? Okay, so that's 450,000. Part B says, which of the countries has the smallest area? Well, the smallest area is going to be the number with the smallest power of 10, isn't it? So if you have looked down those lists, you should know already that Luxembourg is a pretty teeny tiny country, and so is Singapore. So it's going to be out of those two, but if you look, 10 to the 2 is smaller than 10 to the 3. It's definitely Singapore. Singapore is just a teeny tiny island. Part C, Alexa says the area of Australia is approximately 3 times larger than the area of Luxembourg. Is she correct? Show how you decide. Well, just from common sense, I know she is ludicrously wrong. Australia is huge. But anyway, let's look at the maths. So you might think, if she was looking at this, she might be thinking, well, 2.59 times 10 to the 3, which is Luxembourg, isn't it? That's Luxembourg. If you just have a look at the mantissa part, the number at the front, then if you took 2.59 and times it by 3, you would get something around 7.69, which is the mantis part of Australia. But Australia is 10 to the 6. So that is nowhere close. So Alexis is wrong. And the way you can do that, you can just maybe divide one by the other, can't you? So if you type into your calculator 7.69 times 10 to the 6 divided by 2.59 times 10 to the 3, it will tell you how much bigger one is compared to the other one, won't it? Now, to do that on your calculator, you want to be using the times 10 to the x button down at the bottom here. So when I type in the Australia one, I'm going to type in the mantis part, 7.69, and then I'm just going to press that key there once. That's going to give me the times 10, and then I'm going to put in the power, which is 6. So 7.69 times 10 to the 6, divide by, then the second mantissa, which is 2.59, and then I'm going to press that 10 to the 6 button again, and I'm going to put in the power, which is 3. Okay, and that comes out to be 2969. So that's equal to 2969 and change. Okay, so Alexis is wrong because Australia is almost 3,000 times bigger than Luxembourg. Okay, you don't have to write if you don't want to. Right, so Australia is almost 3,000 times bigger. I didn't write my 3 very well either there. 3,000 times bigger than Luxembourg there. Okay, work out the total area of Russia and Australia. Give your answer in standard form to 2 significant figures. Okay, so I'm going to add these two together. Again, it's a calculator paper, so I'm just going to use the calculator function to do it. So 1.71 times 10 to the 7 plus Australia, which was 7.69 times 10 to the 6. So again, I'm just going to use that calculator button on the for powers for standard form on the calculator. 1.71 times 10 button, type in the power, which is 7, plus 7.69 times 10 button, type in the power 6, and that comes out to be 2479,0000. So that's equal to 2479,123 zeros. Okay, now what is that in standard form? What's it in standard form? Okay, so in standard form, the decimal point is currently here. So if I was going to move it between the 2 and the 4, it would go 1, 2, 3, 4, 5, 6, 7 jumps, wouldn't it, over to there? So that means it is 2.479 times 10 to the 7. But that's not 2 significant figures, is it? That's 4 significant figures. So to round it to 2 significant figures, I'm going to round it off after the 4. Next number is a 7, so I'm going to round it up. That makes it 2.5 times 10 to the 7 to 2 significant figures. Okay, so I just rounded it off there. 2.5 times 10 to the 7. Okay, question 17a, expand y plus 5. Okay, so I've got a bracket here that I want to remove. When I've got a single bracket, I just need to multiply everything inside the bracket with the thing outside the bracket. So first off, it's going to be y times y, which is y squared, and then y times 5, which is 5y. So that's just my answer, y squared plus 5y. Now factorising is going back the other way, and that's putting the brackets back in. Okay, so I need to put the brackets back in. Now the thing that goes outside the bracket here is the thing that's in both expressions. Okay, what is common to 4a and 6? What is the common factor there? It's going to have to be the number 2, isn't it? Okay, 2 is in 4a and 2 is in 6. That's the only thing. So it's going to be 2 open bracket something. Now what do you have to multiply by 2 to get 4a? 2 times 2a is 4a, so it's got to be 2a inside the bracket, and then a minus sign, and then 2 times what is 6? 2 times 3 is 6. Okay, so my factorized bracket is 2 lots of 2a minus 3. Finally, I've got 2 lots of 5x minus 4 is equal to 21. Okay, and I want to solve it, which means I want to find x is equal to a number. Okay, now when I've got a bracket like this, I've got 2 choices. Most people just multiply them straight out, but you can just divide both sides by the number in front of the bracket as an easy first step. Now I'm not going to do that in this case because 21 is an odd number and I can't divide it by 2 without getting a remainder. So I'm just going to go ahead and multiply out instead. Okay, so 2 lots of 5x is 10x, 2 lots of negative 4 is negative 8, and that's equal to 21. And then add in 8 to both sides. It's going to cancel on this side because negative 8 plus 8 is 0. They're going to cancel. And then if I then add 8 to 21, I'm going to get 29. Okay, so I'm going to get 10x is equal to 29. Last step, I'm going to divide both sides by 10. On this side it's going to cancel, and it's going to leave me with x, and on the other side 29 divided by 10, well that's just 2.9 then. Okay, so that's my answer, x equals 2.9. Part D says simplify 4e squared f times 5ef cubed. Okay, so to do these we need to multiply like with like really. So I've got 4 and a 5 that I'm going to multiply together. I've got e squared and e, which I'm going to multiply together, and I've got f and f cubed I'm going to multiply together. Okay, so 4 times 5 firstly. 4 times 5 is 20. E squared times e, well, if I've got e times e and I times it by e, I'm going to get e times e times e, or e cubed. And then f times f cubed, well f cubed is f times f times f, so if I multiply it by another f, I'm going to get f times f times f times f, or f to the power of 4. Okay, so my 4 and 5 gave me 20, my e squared times e gave me e cubed, and my f times f cubed gave me f to the 4. It's my final answer, 20 e cubed f to the 4. Question 20, simplify c to the power 5 divided by c squared. Okay, now this is a laws of indices question. I've got 2 numbers with the same base that I'm dividing, so I'm just going to subtract one index from the other then, aren't I? So c to the 5 divided by c squared is going to be c to the 5 take away 2, that's c to the 3. Okay, c to the 3. Simplify d to the power 4 raised to the power 3. So when we've got a base raised to an index and that whole thing is raised to another index, we call this an index of an index, and what we have to do then is multiply those powers together. So this is going to be d to the power of 4 times 3, which is d to the power of 12. Now if you think about it, if you cube something you times it by itself, so you'd be timesing d to the power 4 times d to the power 4 times d to the power 4. Adding up those powers, you can see you're also going to get 12, so you could do it that way as well. D to the power of 12 has helpfully given us the formula for the volume of a sphere, which is 4/3 of pi r cubed. And we're told that a still sphere has a radius of 9 centimeters. So from here to here is 9. Work out the volume of the sphere. So this is just really subbing into that formula. So volume is equal to 4/3 pi r cubed, which is 4/3 of pi times 9 cubed. It's a matter of really typing that into the calculator. So 4 divided by 3 times by pi times by 9 to the power of 3. I make that 3053 and change. So I'm just going to, I'm going to round off 3053. I'm just going to round off to the nearest whole unit. Which would be 4 then, wouldn't it? In part B, we're told that the density of the steel is 7.8 grams per cubic centimetre. Work out the mass of the sphere. Well, density, the formula for density is mass over volume. So rearranging that, so make mass the formula, and mass the subject, sorry, and mass equals, we're going to take this and cross multiply it up here. So mass equals density times volume, which in this case is going to be our 7.8 grams per cubic centimetre multiplied by, just checking the units all the same, yeah, that's in centimetres, so 3054. Now I've still got the stored calculator value on my calculator, so I'm just going to carry on using that. So I'm going to take the answer and I'm going to times it by 7.8, and that gives me 23,818. Mia wants to borrow £6,000 and repay it with interest after 2 years. She sees two offers for loans. Now, offer 1 is compound interest for 3% per year, and offer 2 is compound interest, first year 1%, second year 5%. Mia says, I will pay back the same amount because the average of 1% and 5% is 3%. Is she correct? You must show your working. Well, only way to find out is to do it. So let's see if we can work it out. So let's have a look at offer 1 first. Offer 1. Now, we want to do £6,000. Okay. Now, when you're doing interest, I use a triangle FOM, final, original, multiply, FOM FOM, and I put my finger on the thing I want to find. In this case, I want to find the final. I know the original and the multiplier. So the final is the thing I want to find. The original is what I started with, 6,000, and the multiplier is, well, it's 3% per year. So if I've got 100%, I want to do a percentage increase of 3%, then that's 100% plus 3%, which is 103%, which is 1.03 as a multiplier. Okay, so then my final amount, covering up the thing I want to find, it tells me what to do with the other two things. So my final is going to be the original times the multiplier, but because it's compound interest, I'm going to raise that multiplier to the number of years I'm applying it to. So it's going to be 6,000 times, so it's going to be this raised to the number of years, isn't it? Okay, so it's going to be 1.03 squared. So what's that then? 6,000 times 1.03 squared comes out to be £6,365.40. 6365.40. Okay, now offer 2 I'm going to have to do in 2 steps. So final is what I want to find again. Original is 6,000, and then multiplier for the first year is 1%, isn't it? So it's 101%, which is 1.01. Okay, so then again, final equals original times multiplier, which is 6,000 times 1.01, which is what? It's just 6,060, isn't it? Okay, so that's in the end of year 1. So this is year 1. And then in year 2, my final is going to be my original, which was 6,060 now, because it's what I got from the end of year 1, times my new multiplier of 1.05, because it's 5% in the second year. So 6,060 times by 1.05. So that actually comes out to 6,363. So it actually works out a little bit cheaper. So is she correct? No, she is not correct. I think we've done everything. We've got our two answers, haven't we? This is the first offer 1, and this is offer 2. We found both answers, and we're saying she's not correct. I think that's fine. 3 straight lines are shown. Work out the value of x. Okay, well, they aren't just any old 3 straight lines, are they? We've got 2 lines here that have got arrows on them, which means that these are parallel lines, and we've got a line crossing them. And where have we got that situation going on? It forms various angles, and there are relationships between various angles that are formed. Firstly, if you have a think about that angle there, it is vertically opposite this one, which means that those two are equal. So that one must also be 2x plus 15. And similarly, this angle and this, so that one and that one are equal, but also that one and that one must be equal because they are what we call corresponding angles. So in other words, 2x plus 15, that angle up there must be the same angle as 3x minus 38. Now they might look different because they're written algebraically using different expressions. But if they're the same angle, then these two algebraic expressions must actually be equal. So if we equate them like that, we form an equation in x that we can then go on to solve. Firstly, we've got x's on both sides. So let's simplify it a little bit by subtracting 2x from both sides. So if I take 2x from that side, they'll disappear. And if I take 2x from the other side, it's going to leave me with 15 is equal to x minus 38. Okay. Now, all I need to do is add 38 to both sides. You'll see that minus 38 plus 38 are going to cancel each other out, leaving you with x on the right. And on the left, 15 plus 38, that's 38, 48, 53, isn't it? That tells me that x is equal to 53. A charity collection is made. Information about the amounts given by men is shown in the table. The mean amount given by women was £6.30 per person. Compare the mean amounts given by men and women. Okay, we have a grouped frequency table here, so we can't find an exact mean. What we can do though is estimate it using the midpoints of each of the ranges we've been given and use that as an estimate. So 0 to 5, to find the midpoint of those two, you can add them together and divide by 2. So 0 plus 5 is 5, divided by 2 is 2.5. 5 plus 10 is 15, divided by 2 is 7.5, and 10 plus 15 is 25, divided by 2 is 12.5. Okay, so they're my midpoints. So then we need to multiply those by the frequency and then add them up. So 2.5 times 11 is 27.5. 7.5 times 7, 52.5. And 12.5 times 2 is 25. So adding all those up, so 27.5 plus, 27.5 plus 52.5 plus 25 gives me a total of 105. So then the men's mean is going to be my total, which is 105, divided by the number of people, which is 20. So 105 divided by 20 is £5.25. So it looks like the chaps were the cheapskates and gave £5.25 on average. Now, we have found the mean, but we haven't compared the mean yet. So to compare it, we need to say which one is bigger. So women gave more money on average. So that's our comparison. in the diagram, DC is parallel to AB. So DC is this line here, AB is this line here, and you can see that they are parallel. Okay, so I've got a pair of parallel lines. It's not a parallelogram. Looks a bit like one, but those other two lines are not parallel. Now it asks me here to show that the triangle ABD is isosceles. So where's ABD? ABD is ABD, this triangle here. That's the triangle I'm looking for. And I need to show that it's isosceles. In other words, I need to either show that the lengths of two sides are equal. I'm not going to be able to do that. Or I can show that this angle and this angle here must be equal to each other. Okay, so I know the angle at the top is 124, so I need to show that this angle here then and this angle here are going to be isosceles. Are going to be equal to each other and therefore isosceles. Okay, so how am I going to do that? Well, let's have a look at the other triangle first, the triangle BCD, which is, I'm making a bit of a mess of this diagram. It's this triangle over here, look. Okay, so the blue triangle, I know 2 out of 3 of the angles from the blue one. I've got 152. So the angle at the top there, this angle up here, is going to be, well, the angles in the triangle add up to 180 degrees, don't they? So my 100 plus my 52 plus my angle there equals that angle there, doesn't it? So I know that that angle is equal to 180 minus the other 2. So it's going to be 100 plus 52. 100 plus 52 is 152. So 180 minus 152, what's that equal to? So 180 minus 52 is 180 minus 150 is 30, and 30 subtract 2 is 28. So that angle there is 28 degrees. Okay, so I know that one's 28. How's that helping me? Well, when you've got a pair of parallel lines and a line crossing them, then the angle there and the angle there we call alternate, don't we? And we know that alternate angles are equal. So that angle is going to be the same as that one down there. So on this diagram, that 28 is going to be the same as this angle down here then, isn't it? That one there is 28 because they're alternate. So I now know that that angle there must be 100, that is 28. So then this angle up here then, again, is going to be 180 subtract the other 2. So 180 subtract 124 plus 28. So 124 plus 28 is what? 124, 144, 152, isn't it? 180 minus 152. Oh, look, that's equal to 28 as well. That's also equal to 28. Okay, so we've shown then that both angles are 28 and therefore is isosceles. So we can say that angle ADB is equal to angle ABD, and that's equal to 28 degrees. So triangle is isosceles. Okay, done.
Mr. T, he's the best, helps you ace every test. Maths worries now.